Hey guys, it's my first YouTube video. So today I'm gonna show you a blitz flipping attack by solving a challenge of the box named Flippin Bank. Hmm, looks like it's a server-side code. Yeah. Hmm, this will be our server-side code. Okay. Look, it got key and IV by random bytes. So we have no chance of getting it anyway, or like predicting it. It's impossible. Okay, let's execute it. Okay, from secret import flag module not from. Oh, you have to make a secret. It can be done by creating a file name secret.py on that same directory and keeping what's that variable name, making a variable name flag and keep something in that, so that will work. Looks like now it will work. Yeah, server started now. Let's execute this. Connect with the server through telnet 0.1.7 username. Okay, let's see what can we do here. Now we are here asking for the username. Look guys, there is a try block having assert admin and password called golden boy. This mess not in message, this thing. Okay, so if we use our username admin and password this golden boy, then um, you cannot, it will reply as you cannot log in as an admin from an external IP. Your activity has been logged. Goodbye. Okay, let's try. So, as expected. Now let's do something else. Okay. This gives us a ciphertext. Oh, yeah, encrypted. Okay, they're asking for ciphertext from me. They will try to decrypt as if I have input this thing, but this thing, inputting this thing is not allowed. You can see from here, assert block. Okay, let's see how they are encrypting and decrypting the data. Okay, data.encode, pad size 16 bit. Let me see, it's like byte, yes, byte, and I'll PKCS7, cipher AES new using the key, random IV, and AES mode CBC. Okay. We can use bit flipping attack, very useful for this type of condition here. Okay, let's see what bit flipping attack is about. I mean, yeah, technically they're right. It's actually byte flipping, but yeah, it's a, I don't know why it's a bit flipping so popular. Maybe because you are doing some bit operations down to the byte. There is actually bits. So yeah, both are correct technically. So you can see this picture how the IV and key, for our case it's random, it's used to encryption process. This image is of encryption process. You can see there's the data blocks here. So our padding size is 16 byte. So what will happen, the first 16 byte of data um, will XOR with IV, then in this block cipher encryption. Oh, the CBC means chaining block cipher, block cipher chaining, sorry. So, and using the key, you will encrypt the block of 16 bytes and get the ciphertext. And next time you will use this ciphertext again to XOR with the next 16 byte of data block, and again you will encrypt with the key, and the encrypted next byte block is here, and again the block will be used to XOR with the next bit. So this is how chaining block cryptography works. So they have a great resource, I will say. The encryption process. Here is the decryption process. We also need to see this. Okay. But this decryption process, you have got the ciphertext of first block, I mean 16 bytes, and you have the key. You decrypt it and XOR with IP. You'll get the first plaintext, and next you will get the second block of the ciphertext, and same way you will. The first ciphertext will be used to XOR with the next block of plaintext. Without that, you won't get the right plaintext that you are used for encrypting, that you were encrypted. But in this case, you need that ciphertext. Cipher block chaining here is written. So for cipher block chaining, the way we have encrypted it previously, it needs to decrypt in this way, because by decrypting the block using the key, will not get the correct plain text, because there we because there we didn't put the plain text there. We XOR it with first time IP and the rest of the time with the previous block ciphertext. So yeah, this is necessary to get the plain text. Let's see how the bit flipping will work. Now this image is about modification attack, which is byte flipping on their point of view. So you have the IP key, ciphertext. You have flipped some byte or a byte or single byte of ciphertext of the block. Then you got the decryption, which is variable decryption, and it's not useful for that. Okay, so then that flipped or modified ciphertext will be used to XOR with the next block of plain text. So yeah, the ciphertext will, this way you will modify the plain text value without knowing the key or IP, which is cool. So yeah, what I have said is given there. You do the decryption and XOR with IP for the first block, and rest of the block you do the decryption of ciphertext and XOR with the previous block of ciphertext. So what can we do now? We can do some simple math to see how it will end up. So we can't use the admin here and password as golden bar. So the thing they're actually checking is if there is admin. So how they will get it? Okay, they will get it by message logged username equals admin plus user. Okay. Yeah. Look, it's um, 16 byte already. That means there is the first block. So if we do any modification on the encrypted first byte, I mean here, the modification will take effect on the plain text of the next block, and the next block starts from the user. I mean, in our case, admin. The next block, if we do any modification there, the modification will take place here. So let's try it. How can we exploit this? Okay, so how the encryption process is working? If we input the username as not admin, instead of A we write B, then it will be bidmin. On this case, the first block of this will be on the second block, and first offset here. So the encryption process will be work like the encrypted value of a byte, which is ENC of first byte, and it will XOR with the previous block, which is the ciphertext of the previous block, and we will get B because we have inputted B on the first place. Then doing XOR with the both side, we can get um, so if we do this, then the thing what will happen is we have to XOR B XOR A with the first block of the ciphertext. To get A, we'll do like um, in our case this value will be A. So let's do it by hand. So I will write a script for Python 2. Let's see if I have Python 2 available. Yeah, Python 2 is available for it. And write the script. Port 096. initialize socket. If inet. Okay. Yeah. We got the lit ciphertext. We have to do some splitting on clone. Now it's working as intended. Mhm. So CIP is the value. We have to manipulate CIP here. Ciphertext. Uh, Change it to byte. It's changed to and. Okay, let's try to hexify it. duplicate this. Let's try if this works. Hey, look, it's worked. Yeah. Now we can complete the script. So it's done. Now it can be done with remote. You can easily do it. If you find this video helpful, then like it, or you can subscribe to this channel if you want. Okay, it's for today. Goodbye.